In the next question, many handheld devices such as smartphone and tablet computers containing an accelerometer means using this we can identify the acceleration. These allow change in orientation of the device to be tracked. The student model a simple accelerometer by attaching a small mass on a string at the roof of the car. When the car starts to move, the string is seen to change its position as shown. The direction of the motion of the if car is moving towards light, the object accelerated backward. Because what is the tendency of an object? The object tend to resist the change in state because of their inertia. Complete a free body force diagram for the mass when the car is moving. So if this car is moving and we have to draw a free body force diagram, so free body force diagram represent all of the forces which are acting on the object. So the forces, first thing, the gravitational pull or the weight, which is acting down. And when force is applied by using a wire or a spring or a string, then that is known as a tension. And tension force is always in a direction to pull. In the next part, draw a vector diagram to show the resultant force on the mass is produced. So we have to show a vector diagram. Resultant force means when we add these two vectors, either a parallelogram method or a triangle method, uh, the starting point and ending point will not be same. That means there is a resultant force. So already we drew the free body force diagram in which the weight was acting down and the tension is towards making certain angle according to the string. So how we vector diagram? So we can use a parallelogram method. If I use a parallelogram method, I'll consider them as a side of the parallelogram. So if I consider them as a side of parallelogram and I complete a parallelogram, for parallelogram, the resultant is a diagonal. Like when I complete this parallelogram, so what will be the resultant? The resultant will be the diagonal. Or if I use a triangle method, so weight is the first, I take the first one, the weight, then I drew the tension. It's up to you. You can draw tension first and then the weight, or weight first, then the tension. And what is the resultant? The resultant is from tail of the first to the head of the last. So tail of the first to the head of the last, what we will get? We will get resultant. So both like any one of them. It's not like both diagrams you have to draw. Any one of them, because the starting and the ending point of the vector is not same, the resultant one, it means there is a resultant force acting on it. In the second question, when the string is at an angle of 7 to the vertical, show that acceleration of a car is about 1. So how we can show this acceleration of the car is about 1 when string is making 7 degrees with a vertical, like this is a vertical plane. So that's making 7. So this will be, this is T. The one which is with an angle, this will be T against the angle will be T sine 7, and with an angle will be T cos 7. And the weight is acting down, which is equals to mg. So when we work out, because the vertical plane, there is no acceleration, so we can say that T cos 7, which is upward, balances with the weight downward. But for the other plane, because it is accelerating, that's a direction of acceleration. So it means T sine 7 is equals to ma. That's the resultant force. So T sine 7 is equals to ma. And about the T, we can first find the value of a T, or we can also substitute this, like T is equals to, from this equation I can use T is equals to W divided by cos 7. So in place of T, if I substitute W divided by cos 7, so this will be W and cos 7. So sine 7 divided by cos 7, sine theta over cos theta is equals to tan theta. So this will become W tan 7 degrees is equals to ma, and W is equals to mg. So mg tan 7 degrees is equals to ma. M will cancel with m, so I can say g tan 7 is equals to a. G is gravity 9.8, tan 7 you can work out with a calculator. You will get the acceleration. Is it clear? This part in which we have to calculate a vertical acceleration, which is about 1. The next one is sketch the position of the mass and the string when the car is moving in the same direction at a constant speed. Constant speed or constant velocity means there should be no resultant force. If there's no resultant force, so there will be no resultant force on the pendulum as well, that mass attached to string. And if there is no resultant force, then it will at its original position undergo a much greater acceleration, like compared to 1, if acceleration is more, so it will have a greater angle with vertical the tension. And the third one, dimension decelerating. Look, if decelerating, like first it was accelerating, now it is decelerating. So what happened to this pendulum? It will try to resist the change in state. So as it like originally it was accelerating. This is normally like what happened to you if you are inside the car. If, for example, a car is stationary and a driver presses the accelerator, so if driver presses the accelerator, you tend to lean backward. Why you tend to lean backward? Because your body try to resist the change in state due to inertia. That's why you lean backward. Same thing if the car was accelerating and a driver suddenly applies the brake, so which direction you tend to lean or move? You tend to move forward, to because you are in the state of the motion and suddenly a deceleration or decrease in speed happen, so that's why you will move forward. So same thing happen for this pendulum. If a car is moving with a constant speed, you do not feel any resultant force. That's why you remain at your position. So these are the three positions. The next part, why the string would not become horizontal. Like in any case, why the spring is not exactly horizontal like this. So what is the reason? Because why it was every time making certain angle, or there is always a vertical, because there is a weight acting. So there should always be a component of a tension which matches with the weight. That's why, like weight is acting downward, so there must be a component of a tension which matches with the weight. That's why it was not exactly horizontal. If it was exactly horizontal, it means there is no component of the tension which balances with the weight. So according to the physics, it cannot be remain at this position. Suggest why many devices contain 3 accelerometer right angle. So why 3 accelerometer? Because they can determine the expression in 3 dimension. Like object can accelerate in x-axis, object can accelerate in y-axis, or object can accelerate in z-axis. So why they have accelerometer in all right angle? To determine the direction in all, to determine the acceleration in all the planes. Then page, this was 23, 26. So in page 26, carrying out the stack coin experiment, a student sometime observed that the flick coin did not stop, but it changes the direction it travel. Like what happened, like the coin which is flicked here, after striking, it changes the direction. Basically what happened when the center of the mass is, like if you look these coins from the top, like this is one coin and this is another. If I make a center of the mass and center of the mass, and we flick this coin, so if we flick this coin and the center of the mass are in line to same as the direction of the motion, then what happened, the coin A will move and coin B will stop. But if it was not making like the center of the mass, the collisions are not according to their center of the mass, so in that case what we observe that it will change its direction. So how we explain this, how we mention this? Because what happened in this one, when it collide the first one, the force, there's a force of B on A, and then there's a force of A on B, so it will completely stop B. But here what happened, when it is making certain angle, like not exactly colliding, so the direction of the force, there is a force of like B apply a force and on A, and A apply a force on B. So this force, what it caused the change in direction. So the idea is that the direction of the force on the flicked coin on the stack is in different direction to the initial one. Like if this is the initial direction and the force is also in the same direction to oppose the motion, so it will stop. But here, this is the direction of the motion, but force is not in the same direction or initial direction. That's why this force will cause a change in direction. So in what cases the object will changes the direction? Like if you're looking from the top, like two objects are there, A and B. When you flick, B hit A. Now what about the forces? The moment they collide with each other, there's a force of B on A and there's a force of A on B, and that force is opposite to the direction of the motion. That's why it will completely stop. But what else can happen? If A and B collided with each other, but not in the same, the force which is applied, like example, this is the direction in which B is moving. So this is the direction in which the B is moving. Now, this is a point where B hit A. So there is a force of B on A and there is a force of A on B. But you can see the direction of the motion. This is a motion and the direction of the force are making certain angle. When direction of the force and motion are making certain angle, then what happened? The object will change the direction. But here, when the direction of the motion is opposite to the direction of the force, then the object will slow down or it will decelerate. Is it clear? When the direction of the motion and the direction of the force are opposite to each other, what is the effect of the force? The object will slow down or it will stop. But when direction of the motion and the direction of the force are making certain angle, then what we observe, that the object will change the direction, because the force is having two component, one which is with an angle against the angle, so that component of the force cause a change in the direction. So same thing, like if you have a box and the box was moving towards right, that's a direction of the motion. But if I apply a force in opposite direction, so if the force is in opposite direction, then what happened? The object will slow down or it will stop. But if you have another box and it was having this as a direction of the motion, an example, you applied a force from the bottom to up, so your force is making certain angle to the direction of the motion. What it caused? It caused the object to change the direction. Then page 27. This is again the same idea, that how a person is able to jump. It's the same idea that how the bird is able to fly by pushing the ground. Like a person is there standing on the earth, the ground. Earth is pulling the person, example, up by a force of 600 Newton. The man or the boy will also pull with a force of 600 Newton. But as he pushed downward, and according to Newton pair forces, the downward force is 600 Newton, so upward force is also 600. But as the person tried to jump, he tried to push the ground. So as he pushed the ground, there's more downward force, like example, 600 become 800. So there's more upward force from the ground. But when we check in terms of for the earth, the weight which is 800 downward, sorry, weight is not 800 downward, the weight is 600, and a man is also pulling the earth to the 6, but the ground now is applying a 800 Newton upward. So this create a resultant force, so that's why he will accelerate. So an athlete bend his knees, then springs up into vertical jump. The graph below shows how the reaction force on the ground on athlete vary. Basically, first y decreases, like as we bend our knees to push the ground, so position of the center of the mass changes. That is why the downward force which we apply, or the contact force, decreases. But when we push, that's a maximum force which we applied on the ground. So in this question, show that the mass of athlete is about 80 kilogram. So how we can show that the mass of athlete? This is a upward force which athlete applied. So upward force minus the weight is equals to ma. So that force is about 2,400. I will take. The weight is acting down. So 2,400 is the upward force, the weight gravitational force, and that's equal to ma. Or 2,400 minus mg, is equals to ma. And the mass of athlete is about 80. How we can show that? Look, at this point the athlete does not push, he's standing still. So at this point, it means the weight which is acting down balances with the upward force. So the weight which is acting down balances with the upward force. At this point, the upward force is 700, 600, 700, and 750. So 750 is the upward force that matches with the weight, or 750 is equals to weight mass into gravity. So gravity is 9.8. So 750 divided by 9.8, we will get the mass. As he bend his knees, you can see as he bend his knees, the position of the center of mass changes. So contact force with the ground decreases. Then he pushed the ground, so greater contact force, more upward force, which create a resultant force against the gravitational force, and he will accelerate. The small dot on each diagram represent the center of the gravity. What is meant by center of gravity? It means the point where the weight of an object act. Then page 28. Between 0.25 to 0.75, the athlete bend his knees. As a result, the center of the gravity moves lower. Explain how the graph shows the acceleration is produced, how the graph shows that an acceleration is produced as athlete bend his knees. So as the athlete bend his knees, so what happened? There's a change in the resultant force. So you can see for the part B2, so as he bend his knees, the reaction force is less and the weight is more. So there will be a resultant downward force, hence there is acceleration, because whenever there's a resultant force, there's acceleration. So as he's bending his knees, position of the center of mass changes. So less upward force, more downward force is there. Because the weight is not changing, only the contact force with the surface is changing. So contact force decrease, the weight is now more than the contact force, because initially when he's standing straight still, so weight is balances with the normal contact. So if normal contact was 750, the weight was also 750. But when he bent his knees, the upward force decreases. So if the upward force decreases, the weight remains 750. So 750 Newton is the weight downward, and but the upward force is less, like example, maybe 200. So you can see resultant force is there. Whenever there is a resultant force, there is always an acceleration. Then part D, the maximum reaction force was reached at 0.9 second. Calculate the acceleration of athletes. So how we can calculate the acceleration? This is the upward force, that's about 200, 2400 or 2450. The weight is already there, that's 750. So the upward force, the reaction force minus weight is equals to ma. So reaction force is there 2400, weight is there 750, mass we already worked out in the previous part, and we can find the acceleration. This is ma. So we can find its maximum acceleration. Then page 33, question 13. In this question, the student has two magnets A and B. A magnet A is smaller and a weaker than magnet B. The weight of magnet A is determined by using a digital spring balance, and the weight of magnet B is using a top pen balance. When the magnet A is at position above the magnet B, the attractive force is there between them. How the readings of the two balance changes. Look, here the weight is acting down, weight is also acting down. But what happens as the two magnets are pull, like the weight is for magnet B, weight is acting down. For magnet A also weight is acting down. But as there is an attractive force, so for attractive force means direction of the force towards each other. So because of this attractive force, when we find the resultant force on magnet A, so both forces are in the same direction. So for magnet A, what we observed, the reading on the balance or reading on the digital spring balance will increase because the weight and the attractive force both are acting in the same direction. But for magnet B, the weight is acting down and so the weight is acting down, then the attractive force is acting up. So weight minus attractive force, the resultant force, because here the resultant force is due to the difference of weight and attraction. And here the resultant force is equals to sum of weight and attraction. So what happened to the reading on the digital balance, spring balance increases and the digital and the top pen balance will decrease. So you will use the Newton law for this. Like when you mention the answer, first you will mention as a magnet A is pulling the magnet B will also pull magnet A, equal force but in opposite direction. And the reading of A will increase. Why? Because both forces are acting in the same direction. This create a greater resultant. Whereas reading on the balance will decrease because the two forces are acting in opposite direction. Is it clear? So these were the doubts related to the exercise last week homework, Newton laws.